Modeling planet formation, water tornadoes, and Kepler's laws. Understanding planet formation through water tornadoes. Have you ever wondered how scientists model the formation of planets? It might surprise you to learn that one of the most effective methods involves something as simple as spinning water in a circle. This innovative approach was recently highlighted in a study published in the monthly notices of the Royal Astronomical Society letters by researchers from the Max Planck Institute for Astrophysics and the University of Greifswald. The concept behind this research is reminiscent of a classic science experiment that many children encounter in school, creating a vortex in a bottle. While the researchers' system is undoubtedly more intricate than a child's simple vortex experiment, the fundamental principle remains the same. In a protoplanetary disk, the gas and dust that eventually coalesce into planets orbit around a newly formed star, engaging in a gravitational ballet that leads to the formation of protoplanets, the building blocks of future planets. The water vortex mimics this dynamic, with the vortex acting as the central gravitational force of the system. Traditionally, scientists have relied on simulations to study these systems. But modeling the complex interactions of individual dust particles merging into larger bodies poses significant computational challenges. Moreover, simulations must be validated against experimental data, which can be hard to obtain due to the limited availability of time on powerful telescopes. The power of water vortices. Unlike simulations, water vortices can be generated at will and sustained for as long as needed. This isn't the first time such a method has been employed to replicate planetary formation, but earlier models were constrained by limited ring-shaped zones, which restricted their effectiveness. The new system, however, more accurately reflects the characteristics of known planet-forming disks. From an engineering perspective, creating this model is relatively straightforward. The setup consists of two transparent cylinders of different sizes stacked vertically, with a larger cylinder positioned on top. A drain tube is placed at the bottom of the smaller cylinder, while two nozzles pump water horizontally into the bottom cylinder using a standard aquarium pump. When enough pressure is applied, the water spills over into the larger cylinder above, where the real magic occurs. To evaluate their apparatus, the researchers introduced beads into the vortex and monitored their movement to see how closely it aligned with observational data. By capturing the beads' positions with a high-speed camera, they were able to run an algorithm to trace each bead's trajectory. The laws of planetary motion, famously formulated by Johannes Kepler in the early 1600s, serve as a benchmark for assessing these models. The complexity of orbital mechanics. As discussed by Fraser and Dr. Renu Malhotra, orbital mechanics is a complex field. In the case of the new water vortex, it performs admirably in terms of two of Kepler's laws. That a planet or bead, in this instance, covers equal areas in equal times, and that there is a specific mathematical relationship between an orbital period and its size. The beads in the experiments conform well to these laws. However, like other vortex-based experiments, it struggles with Kepler's first law, which states that planets follow elliptical orbits. Instead, beads in smaller vortices tend to trace spiral paths. This issue could potentially be resolved by scaling up the system, which would enhance the stability of the flow pattern and facilitate the formation of elliptical paths. The researchers plan to develop the model further by increasing its size to allow for stable elliptical paths within the swirling vortex. However, this remains a topic for future research. For now, they will continue to refine the benchtop version, allowing them to revisit one of the most beloved science experiments from childhood for an extended period. Join the conversation. What do you think about using water vortices to model planetary formation? Could this approach revolutionize our understanding of how planets are born? Share your thoughts in the comments below.